Everyone. I'm going to be explaining as to why we can write the integral from a to b of f of x dx and why it is equal to the limit as n approaches infinity and n of the sum from I is equals to 1 to n of f of x sub I times delta x. And I'm going to show you how did we get this. Now, first thing we must first do is, let's suppose we have a function that is continuous. So we have y is equals to f of x. Now, suppose we have a graph and then a curve. Now, suppose we have an area that is bounded by two vertical lines. Let me write this here. Now, suppose we have an area that is bounded by two vertical lines, the curve obviously, and then the x-axis. So basically this area right here. Now this vertical line can be written as x equals to a and x equals to b. Now our goal here is to find the area under the curve and is bounded by x equals to a and x equals to b. First thing we must do is to split the interval AB into several subintervals such that the width of each subinterval, so we get subintervals, such that the width of each subinterval, say delta x, is equals to b minus a, that is all over to the number of all subintervals. Now, so the endpoints of each subinterval can now be given by x sub 0 is equals to a, basically. So this is what it basically is. So this is this right here. Now we can also get x sub 1 is equals to a plus delta x. Now we also get, now why a plus delta x? Because we go from here, we go from here, and that is added with delta x. Therefore, we get this thing, or just this thing, and so on. So we also get x sub 2 is equals to a plus 2 times delta x, and so on. So we get x sub 3 is equals to a plus 3 times delta x. Yeah, basically it we can have infinitely many sub intervals. Now now for each sub interval we can try to draw a we can try and draw a rectangle. Now the length of this rectangle is, basically we can get, or we can pick a sample point from the interval x sub I minus 1 to x sub I. So say we have x sub, this is our sample for x sub I, and then its length can now be given by f of x sub I, and we have an asterisk because that indicates that we are using a sample point. So we have f of x sub I as our length. So now the width of the subinterval can now be given as x sub I minus x sub I minus 1. So basically this right here. So that's delta x. Sorry. So our width is delta x. Now that we have that, we can now find the area of this rectangle by multiplying our length, which we got was f of x sub I times its what do you call this, its width, and then we will get the area of this one rectangle. Now remember our goal was to find the area underneath the curve by having many rectangles and summing their areas of each rectangles until we can approximate the area underneath the curve that is bounded by two vertical lines, the x-axis, and of course the curve. Now we can do a summation rule. We can use the sigma rule. So basically it tells us that the sum from I is equals to 1 to n of the area of each rectangle, which again is given by f of x sub I times the width delta x. We got that. Now, how? No, basically, this basically tells us that it is the area under the curve, but we need to be more accurate. Let's introduce infinity. Now, what infinity does is we can have infinitely many basically infinite amount of rectangles until we get closer and closer and closer to the correct approximation of the area underneath the curve, or of this certain shape. So now let us use infinity. How can we use infinity on this sigma, on this summation? Now we can use infinity by using limits. Now what limit basically tell us that as the number of rectangles reaches infinity, or it will never reach infinity, but as the number of rectangles gets closer and closer to infinity, the sum of the area of each rectangles will be closer and closer to the approximation of the area underneath the curve. So let us use limits. So now we can write the sigma, or the summation. So I is equals to the sum from I is equals to 1 to n of f of x sub I, and that is multiplied by delta x, its width. So we have that. That is basically it. As you can see, we can now write that as the integral from a to b of f of x dx. That's it. Thank you for watching.